Hi everyone, so today's video is about cross-site scripting or XSS. Before diving into it, you have to know that XSS are based on JavaScript. So it's helpful to have a basic understanding of the language. However, none of the examples are overly complicated, and I'm gonna explain each of them too. So cross-site scripting is classified as an injection attack, where a malicious JavaScript gets injected into a web application with the intention of being executed by other users. Also, cross-site scripting vulnerabilities are extremely common. Here are some XSS findings and reports that got paid very well, like this one from Steam Chat or another one that was found on HackerOne. What is an XSS payload? And first, what is a payload? An XSS payload is the JavaScript code we wish to be executed on the target's computer. There are two parts to the payload: the intention and the modification. The intention is what you wish the JavaScript to actually do, and we'll see that in the examples that we'll see just after that. And the modification is the changes to the code we need to make to execute, as each scenario is different depending on where we are. Here are some examples of XSS intentions. So a proof of concept. The proof of concept is the simplest payloads demonstrating that an XSS is possible on a website. We often do it by causing an alert to pop up on the page with a string of text. For example, here. So as you can see, the alert here, it's a JavaScript function that will cause a pop-up to appear. Another example with session stealing. Here, we would like to steal the details of a user session, like a login token, and these details are often kept in cookies on the target machine. So for example, we can use this. So document.cookie is where we find the cookie. Then we put it into the function btoa, which will encode the cookie into base64. Then this base64 value of the cookie will be appended or concatenated to the URL and then sent as a request with the fetch function. Another intent would be to put a keylogger. So for example, here, the pressed key is encoded into base64 before being concatenated to the URL and then sent via the fetch function. Another example, here we're talking about business logic. In this type, the payload is a lot more specific than the two previous ones, as it involves calling a particular network resource or a JavaScript function. For example, let's imagine a JavaScript function for changing the user's email address called user.changeEmail. So the payload would look like this. Here, the attacker would change the email of a victim user with his own email and making it possible for him to reset the password after. Now we'll see different types of XSS vulnerabilities. The first one are reflected XSS. What are reflected XSS? They happen when user-supplied data in an HTTP request is included in the web page source without any validation. For example, here we have a website where if you enter an incorrect input, an error message is displayed. So the content of the error message gets taken from the error parameter in the query string and is built directly into the page, like this. So you see the error message here is inside the URL, and then it's directly put into the page source. So the application doesn't check the content of the error parameter, which would allow the attacker to insert malicious code, for example, like this. So they would be put in a script, a JavaScript inside it, and send it, and we get this here. So how can an attacker use it? The attacker would first send a link to the victim that contains a malicious payload. The victim clicks the link and is taken to the vulnerable website. So the link containing the attacker script is executed on the website, and then the data the attacker script gathered is sent to them. And they could steal the victim's cookie, which would allow the attacker to take over the victim's account. So here the attacker could send links or embed them into an iframe on another website containing a JavaScript payload to potential victims. The browser will execute the code, potentially revealing session information, customer information, and so on and so forth. So how to test for reflected XSS? For that, we'll need to test every possible point of entry. And this includes parameters in the URL query string, the URL file path, and sometimes HTTP header. Once some data which is being reflected in the web application have been found, we'll need to confirm that we can successfully run JavaScript payload. And the payload will depend on where in the application the code is reflected. Stored XSS is the second type of XSS we'll talk about. As the name infers, the XSS payload is stored on the web application in a database, for example, and then it gets run when other users visit the site or web page. For example, a blog website that allows users to post comments, but if these comments aren't checked for whether they contain JavaScript or filter out any malicious code, and if we now post a comment containing a JavaScript, this will be stored in the database, and every other user now visiting the article will have the JavaScript run in the browser. So here the attacker would insert malicious payload into the website's database. For every visit to the website, the malicious script is activated, and then the data the attacker's script gathered is sent to them. They could steal the victim's cookie, which would allow the attacker to take over the victim's account. So the malicious JavaScript could redirect users to another site, or steal the user's session cookie, or perform other website actions while acting as the visiting user. Now, how to test for them? For that, we'll need to test every possible point of entry again where it seems data is stored, and then shown back in areas that other users have access to. For example, comments on a blog, user profile information, website listings. Sometimes developers think limiting input values on the client side is good enough. So changing values to something the web application wouldn't be expecting is a good source of discovering stored XSS. For example, an age field that is expecting an integer from a drop-down menu, but instead we manually send the request rather than using the form, allowing us to try malicious payloads. Once we found some data which is being stored in the web application, we'll need to confirm that we can successfully run our JavaScript payload. And the payload will depend on where in the application the code is reflected. The third type of XSS we'll talk about is DOM-based XSS. So first, what is the DOM? The DOM stands for Document Object Model, and it is a programming interface for HTML and XML documents. It represents the page so that programs can change the document, structure, style, and content. A web page is a document, and this document can be either displayed in the browser window or as HTML source. So here's a diagram of the HTML DOM. So you get the root element, which is in HTML, and then different element like head, and then sub element like title, and then the value of the title, which is my title, and same for the body element, and so on and so forth. So how to exploit the DOM? DOM-based XSS is where the JavaScript execution happens directly in the browser without any new pages being loaded or data submitted to backend code. So the execution occurs when the website JavaScript code acts on input or user interaction. For example, here we have an attacker will craft a URL containing the malicious string and send it to the victim. So the user is tricked into opening the link and requesting the malicious URL from the website. The website receives the request but does not include the malicious string in the response. The user's browser executes the legitimate script inside the response, causing the malicious script to be inserted into the page. And then the user's browser executes the malicious script inserted into the page by the client-side code. And finally, the user's sensitive information is sent to the attacker server. Another example would be the website's JavaScript getting its contents from the window.location.hash parameter and then writing that onto the page in the currently being viewed section. The contents of the hash are unchecked for malicious code, allowing an attacker to inject JavaScript of their choosing onto the web page. So, crafted links could be sent to potential victims, redirecting them to another website or stealing content from the page or the user's session. How to test for DOM-based XSS? We would need first to look for parts of the code that access certain variables that an attacker can have control over, such as window.location.x, document.referrer, location, and so on and so forth. And we need to see how they are handled and whether the values are written on the web page's DOM or passed to an unsafe JavaScript methods such as eval. There will be in the description below some references where you can look at the different parameters and methods that can be used and that you could search for. And the last XSS type that we'll see today is the blind XSS. So blind XSS is similar to a stored XSS. The payloads get stored on the website for another user to view. But in this case, you can see the payload working or be able to test it against yourself first. That's why we call it blind XSS. An example, and a website has a contact form where you can message a member of staff and the message content doesn't get checked for any malicious code, which allows the attacker to enter anything they wish. These messages then get turned on into support tickets which staff view on a private web portal. As a potential impact of this type of attack, if an attacker uses the correct payload, the attacker's JavaScript could make calls back to an attacker's website, revealing the staff portal URL, the staff members' cookies, even the contents of the portal page that is being viewed. Now the attacker could potentially hijack the staff member session and have access to the private portal. How to test for blind XSS? When testing for blind XSS vulnerabilities, we need to ensure that the payload has a callback, usually an HTTP request. A popular tool for blind XSS attacks is XSS Hunter. This tool will automatically capture cookies, URLs, page contents, and more. So the payload is the JavaScript code we want to execute either on another user's browser or as a proof of concept to demonstrate a vulnerability in a website. So the payload could have many intentions, from just bringing up a JavaScript alert box to prove we can execute JavaScript on the target website to extracting information from the web page of our user's session. So how our JavaScript payloads get reflected in a target website's code will determine the payload we need to use. Let's just open the lab. We're here onto level 1 and it says enter your name. Let's just enter something and see. Then let's see the page source. So it's just put there just after hello. So let's try just as a proof of concept, alert. Okay, let's try this. And here we go. We have an XSS here. So this one was the easiest payload possible. Now let's do that again, same way. Add a name. This time, as you can see, my name is more in a text area. So let's open the page source. It's in an input like this. So we have it here. Now, if we want to put the script, we need to be outside of this. But it would put us like if whatever we put in that in here will be put there. So instead of this, we need to put something that gets us out of here. So we need to do something like this. So by adding this, let's just copy this again. If I add this part here, it will close the input tag. So now, after closing the input tag, I can open the script tag. So script, and close it. And in between, put in our alert. Oops. Here we go. And let's try this and see if it works. I mean, it should work. And it does work. Let's look at the page source and again and see how it did. So as you can see, this is what I added in the beginning, just to close the input tag. Once I closed the input tag, I was able to add my script. Yeah, and that's how it worked. Now let's go on to level 3, try again. So again, view page source and see how it works. So now the name is inside a text area tag. Like before, we need to get out of here. So if I need to get out of here, I can just add this tag again. So I'm putting this at the end instead of my name. I'm putting this to be able to end the tag. Then add in our script tag. So if I had to change it here, that's instead of the name that I put before, that's how it would look like. So I just close the text area tag and then put the script that I want to execute. So let's copy this here and see how it works. And it works. Okay. And again, let's look at the page source just to see how it did. Like I said just before, we closed the text area, added the script, and that's it. Let's go on to the next level. Again, same as before. We try it. It looks like the first one. It's here. So it got the name from this using this. Let's still try. So if it would be like the first one, let's try it like the first one. But there's nothing. We don't have the pop-up. So, and in fact, when we look at the page source, what we see is the name here, it's hello, and then there is something here, so name. But the value of this came from this script. As you can see, here is the name that I put in. So because we are here in already a script, things have to change. So we are already into a script tag and we want to get out of here. So what does that mean? There is the apostrophe and the semicolon that we have to add to be able to end this. So let's write it down here. Once we've put this, we can add our script. So we don't have to add the tag script because we are already inside of it. We just put alert. And let's copy it, put it here, and try. It doesn't work. And why doesn't it work? So there is a thing that we forgot about. If I add this like this, there's still these two things after, so they will be added like when I put it here. When I put it, it will be added here. So it closes this thing, this one. It adds this one. However, there's this. So to be able to make it, so what we are gonna do is put it in a comment. For that, we'll add this. The 2 slashes will make it a comment. And here we go. This time it works. Let's go on to level 5. Same as before. Try in again. View the page source. And what we can see here. So here the name has been put directly, but when I put the script, it didn't show up. So if we go there, and as you can see, these two, where normally there is the word script written inside, has been removed. So normally here you would find what I put first was like this, but they were removed. So probably there is a filter removing the keyword script. So we need to bypass that. And to do that, we can just put it like this. Like try and put in another word like script inside of it. So when it passes the first time, the filter will remove this. But because there isn't a second pass, it would be like removing this. And then the word script gets back together. So let's copy this and put it here. And it works. Okay. Let's go to level 6. So in level 6, it says enter an image path. Oh, what a cute cat. We have here image, source, and the cat image. Now, if you remember in the second one, we were into something like this in the level 2. So if I want to get out of here, I would need to put this and then add the scripts and try it. So this is the same thing we did for level 2, but it doesn't work. So there is a filter removing that part. So let's take a look at the page source and see what happened. And if you see here, the angle brackets that I've added have been removed. because we went from this with all these angled brackets to this. None anymore. They were all removed. So if they are all removed, what we could do is, instead of that, so what we can do, because this is preventing us from escaping from the image tag, we can get around the filter by taking advantage of the additional attributes that the image tag has. For example, the onload attribute. So here, that's what exists. So what we can do is close the source, then have the onload attribute, and for the onload attribute, we'll add the alert. And we don't need to put any other thing. So this is what we had to add. So let's try it. Let's put it at the end of the image source first, because we are using the onload attribute. So, and we have it here. Payload successful. Nice. We could have used also what we call polyglots. So an XSS polyglot is a string of text which can escape attributes, tags, and bypass filters all in one. We could have used the following polyglots on all 6 levels we've just completed, and it would have executed the code successfully. And this is the code. Let's try it just on the last level. And here we go. Works perfectly. For the last task, we will go over blind XSS vulnerability. However, we need to use the attack box because when using our own VM and the VPN, we can encounter some issues with receiving the request. So I tried it earlier today, but it didn't work. However, with the attack box, no problem. It worked perfectly. So let's do that. Right here, first let's go to the customer sign up. And try and make a support ticket. So if you remember, or when we did content discovery on this machine in one of the past videos, there was a support ticket, and we know that this ticket will be read by someone else. So let's try and create a ticket and see if there is any XSS vulnerability there. So whatever I put was directly put there. View page source. So as you can see, it's in the text area, like level 3 before. So let's try and make and get out of this text area and then see if the script gets loaded. So let's go back, create a new ticket. And create the ticket. Let's open the ticket and see. And yeah, so there is an XSS vulnerability here. So now that we know that there is an XSS vulnerability, so let's create another ticket and expand the payload even further and increase the vulnerability's impact. So for now, the impact is mostly nothing, but because it's a support ticket, we know that a staff member will also view this ticket, which could get to execute JavaScript. So Some of the information that we could want to extract from another user would be their cookies, which we could use to elevate our privileges by hijacking their login session. So to do this, like our payload will need to extract the user's cookie and exfiltrate it to another web server of our choice. So before writing the payload, we'll first need to set up a listening server to receive the information. So using Netcat with the switch N for no resolve of any IP address into domain name or host name, L for listening, V for verbose, and P for port. And we'll put the port that we want our Netcat, our machine, to listen onto. So here it's listening on port 9001. Now that we have that, we can create a new ticket with our new payload. So test. And here still we have to get out of the text area. Once it's done, we can add the script. And like before, we'll use fetch to send an HTTP request, and we want to send it to our machine. So for that, we'll have to use the IP address of the attack box, which is here. And because Netcat is listening on port 9001, we'll have to put 9001 here. Then we wanted to send a parameter. So I'm just going to use the parameter cookie to say that it's a cookie that will be sent. It's a query string. And in this query string, we'll put the victim's cookie. So we'll append this with the victim's cookie encoded into base64. So document.cookie, and then we are out from fetch and then it and closing the script tag. Now that the script tag is closed, everything is done normally. Okay, let's get back to the terminal, and here we go. So it sent back this. We can copy it, and because it was in base64, we just open CyberChef from base64, and here we go. That's the answer. A bit more information. So if we wanted to prevent XSS, what we can do is input validation again and sanitization. So each variable in a web application needs to be protected. So all variables need to go through validation and sanitization. And also output encoding. Variables shouldn't be interpreted as code instead of text. HTML sanitization. Sometimes users need to other HTML, for example, for styling content inside an editor. And so we need to sanitize that using content security policy. It's an allow list that prevents content from being loaded, even though this isn't enough, but it's still a good thing. Using web application firewall that will look for known attack strings and block them. However, they don't address the root of the problem, like input validation and sanitization, because new bypass techniques are discovered regularly. And for more resources, you'll find all the links for these down below in the description box. Thank you for watching. I hope you enjoyed this video, and until next time, bye!